Let's study selection sort, its analysis in data structure, how selection sort is different from other sorting techniques. Before we start, we see what is sorting. Sorting is arranging the input sequence in either ascending or descending order. Sorting is also defined as the process that organizes a collection of data into either ascending or descending order. The different types of sorting methods are internal sort and external sort. Now, external sort is with the memory, so it is given as external memory. And internal sort is data is stored in the computer's main memory. And external memory, data is stored on the external devices. That is where the difference in internal and external sort happens. Usually, all the simple sorting techniques, that is the bubble sort, the selection sort, the quick sort, the merge sort, are all the example of internal sorting. When we go to hashing, it is an example of external memory where the data is stored on the external device. Now, what is a selection sort? The list is divided into two sublists, sorted and unsorted. We find the smallest, that is the minimum element, from the unsorted sublist and swap it with the elements at the beginning of the unsorted data. We will see this actually how it works. After each selection and swapping, the position of the sorted elements are fixed, thereby increasing the number of sorted elements and decreasing the number of unsorted ones. Each time we move one element from the unsorted sublist to the sorted sublist, we say that we have completed a sort pass. So that is known as a pass of a sorting technique or a sorting algorithm. A list of n elements requires n-1 passes to completely rearrange the data. So for the selection sort and the bubble sort, the number of elements in the list, so the number of passes it will require will always be n-1. Now these are the steps for the selection sort. The first element is always considered as the start of the list and comparison starts from there. Find the minimum element from the list and swap the values of the first element with the minimum element in the list. If this is my original list, 25, 86, 56, 13 and 45. So what happens is after pass 1, the list should become 13, 86, 56, 25 and 45. Now how this has happened? You will see this is my original list, and in this original list, first element is considered as the start of the list and comparison starts from here. Now from the remaining list we find out the minimum element, and the minimum element is 13. So the value of 13 and 25 is swapped over here. So after pass 1 we get 13, 86, 56, 25 and 45. This is my original list. We see actually what happens is 13 we find out, so 13 and 25 are swapped. Now after pass 1, this is my input to pass 2. So what we do next? We find out the minimum element from this list. So the minimum element is 25. So 25 and 86 will be swapped. So after pass 2, my list becomes 13, 25, 56, 86 and 45. So in pass 3, this is my input. So from these remaining 3, we find the minimum element, and the minimum element is 45. So 45 will be now swapped with 56. So after pass 3, 13, 25, 45 have got the fixed location, 86 and 56. So minimum element is 56. So 56 will be swapped with 86. So after pass 4, I've got my fixed location. As there are only 5 elements in the array, so 86 has got its position automatically fixed. So the sorted list is 13, 25, 45, 56 and 86. So this is my sorted list. So you have seen the number of passes are n-1 as there are 5 elements in my array. So number of passes are 4. Carefully see the video for the bubble sort also, because there's a minor change between selection sort and bubble sort. Now the selection sort advantages. The main advantage of selection sort is it performs well on small list. We can call it either a disadvantage that it does not work well on the larger list. It is in place sorting algorithm. No additional temporary storage is required beyond what is needed to hold the original list. So it works well on a small array of elements. The primary disadvantage of selection sort is its poor efficiency when dealing with huge lists of items. Its performance is easily influenced by the initial ordering of the items before the sorting process. Now let's see the program for the selection sort. Hash include stdio.h void main array of the size 100 n I j min and swap. Printf enter the elements, so we enter the elements over here of 5 and enter the elements. So using a for loop, 5 elements are entered. I is initialized to 0. While I is less than n, that is, we using the while loop over here, not two for loops. So while I is less than n, I is initialized to 0. Min is equal to a of I. So this is initialized as the first element. So min is equal to a of I. So this becomes my minimum element of the list. For j is equal to I plus 1. So j will start from here. We say we have 5 elements, so we've written by default 5 over here, or you can replace it with n. If min is greater than a of j, is my min greater than a of j? Min is 25, a of j is 86. No, it is not. So it will not enter this loop. End of if, end of for. So I will be incremented by 1. I will reach, j will incremented by 1, sorry, and j will reach here, so it becomes 56. Min is greater than a of j? No, min is not greater than a of j. So it will again be incremented, this for loop, and j is incremented. Now j becomes 13 over here. So if min is greater than a of j, yes, min is greater than a of j. So temp is equal to a of I. When I say temp is equal to a of I, so what is temp is equal to a of I? A of I is 25. So this will be swapped. So temp is equal to a of I, temp gets the value of 25, a of I is equal to a of j, so a of j gets the value of 13, and a of j is equal to temp, so it gets the value of 25. So the value over here will be 25 initially, temp gets the value, a of I is equal to a of j, so the value will be 13, and here a of j will become 25. Next, again the for loop will be incremented, it is here, but now my min is what? 13. As my min is 13 over here, min I say min is equal to a of j, so min has now become 13. So is 13 less than 45? Greater than 45? No. So this loop will end. So this is how after pass 1 I'll get the list of elements. 13, 86, 56, 25 and 45. So this will continue till all my elements are compared. And printf, the sorted list in ascending order, I is equal to 0, I less than n, I plus plus, and the list will be printed over here. Now what is the time complexity for the selection sort program and the algorithm? For best case, that is omega n raised to the power of 2. Average case is theta n raised to the power of 2. And worst case is big O n raised to the power of 2. Now why it is n raised to the power of 2? Because there are two loops which are executing in which all these statements will be done, and space complexity is big O n because it takes whatever is the size of my array. Why this is n square? If I'll just go back and show you, it is n square because this is where my n is working and these are the two loops which are executing. So the time complexity is n square for best case, average case and worst case for the selection sort. Selection sort has an execution time of n into n minus 1 by 2, and the time complexity for the execution is n into n minus 1 by 2 for the complete selection sort. Thank you.